questions 11 through 20 on the 2007 Grade 7 Gauss Math Contest. In the Fibonacci sequence 1, 1, 2, 3, 5, each number beginning with the 2 is the sum of the two numbers before it. For example, the next number in the sequence is 3 plus 5, which equals 8. Which of the following numbers is in the sequence? Let's write out the sequence and let's see what we get. So 3 plus 5 will be the next number, which is 8. 5 plus 8 will be the next number, which is 13. 8 plus 13 will be the next number, which is 21. 13 plus 21 will be the next number, which is 34, and so on, ... And my answer choices, the one that is in this list is 21. So number 11, the answer is B. The grade 7 class at Gauss Public School has sold 120 tickets for a lottery. One winning ticket will be drawn. If the probability of one of Mary's tickets being drawn is 1 over 15, how many tickets did she buy? Let's say she bought X tickets and there's 120. That probability in lowest terms is 1 over 15. So you cross multiply. 15x is equal to 120, and therefore x is equal to 8. So she bought 8 tickets, and that's why her probability is 1 over 15. So number 12, the answer is D. What is the largest amount of postage incense that cannot be made using only 3-cent and 5-cent stamps? Well, let's see. Let's go through these. 7. Can you make a 7-cent combination with 3-cent and 5-cent stamps? And the answer is no. So this is a candidate for the correct answer. 13. Yes, you can have 2 5-cent stamps and a 3-cent stamp. That would be 13. So this can be made, so that's not going to be one of the answers. 4, you can't make a 4-cent combination with 3 and 5, right? So this is a candidate for the correct answer. 8, yeah, 5 and 3, that would be 8. 9, 3, 3, and 3. Now, one thing I wanted to mention about this question is the wording is not perfect. Right here, this word right here, and makes me think that you have to use both 3 and 5-cent stamps. They should really have put and or, because if it's and, you have to use both 3-cent and 5-cent stamps, then you couldn't do this, right? Because this only involves 3-cent stamps. So some people might choose this because they say, well, you can never make 9 cents using 3-cent and 5-cent stamps. But in this question, according to the way they have done it, it really is and or, even though that's not the way they wrote it. So this is gone because those can be made. So therefore, of the two answer choice remaining, the largest is 7. So number 13, the answer that they have is A. Harry, Ron, and Neville are having a race on their broomsticks. If there are no ties, in how many different possible orders can they finish? All right, let's see. Harry, Ron, and Neville. So I'll make the order first, second, and third. You can have Harry win, Ron come second, Neville come third, or you can have Harry win, Neville and Ron get second and third respectively. Or you can have Ron win, Harry and Neville go there, Ron win, reverse the order for Harry and Neville. Or you can have Neville win, and in a very similar way, Harry and Ron would make up the next 2 places. So there you go. That's 6 ways, and therefore number 14, the answer is B. How many positive whole numbers, including 1, divide exactly into 40 and 72? 40 is equal to 2 times 2 times 2 times 5. 72 is equal to 2 times 2 times 2 times 3 times 3. So these are the prime factors, right? Factors of 40 and 72 respectively. So we have to find common ones. Well, the first common one they give you is 1. Another common one that's very obvious is 2. But then after that, you have to multiply some of these guys. 2 times 2, 4, and 2 times 2 times 2, which is 8. And that's it. Those are the only whole numbers that divide exactly into 40 and 72, so therefore number 15, the answer is C. In the diagram, each scale shows the total mass of the shapes on that scale. What is the mass of a triangle? So we have square plus circle is equal to 8. We have 2 circles plus square is equal to 11. And we have circle plus 2 triangle is equal to 15. Okay, so where would you like to begin here? Well, this guy here, break it up into circle plus square. And we know that circle plus square is equal to 8. So circle plus 8 is equal to 11. And therefore circle is equal to 3. So I'll substitute that into here, and we get 3 plus 2 triangle is equal to 15. And therefore 2 triangle is equal to 12. Triangle is equal to 6. So number 16, the answer is D. To rent a kayak and a paddle, there is a fixed fee to use the paddle, plus a charge of $5 per hour to use the kayak. For a 3-hour rental, the total cost is $30. What is the total cost for a 6-hour rental? So $5 an hour times the number of hours plus the cost of the paddle is basically how we determine the price. When the number of hours is 3, this becomes $30. So instead of H, I put 3 plus P. This allows me to figure out the cost of the paddle. So P is therefore equal to 15. Now we have to figure out the total cost for a 6-hour rental. So this time H is equal to 6. So it's going to be 5 times 6 plus P, which we just figured out was 15. So this is 30 plus 15, and that is equal to 45. So number 17, the answer is C. Fred's birthday was on a Monday and was exactly 37 days before Pat's birthday. Julie's birthday was 67 days before Pat's birthday. On what day of the week was Julie's birthday? So, many ways of doing this question. I guess we'll just do it the old-fashioned way, which is just write out the calendar. And then let's first talk about Fred, right? So Fred, his birthday's on a Monday. So he's down here. And I'll just write F for Fred. And then 37 days before his birthday is Pat. So if you subtract 7, you'll get right back to this exactly 1 week before. So it's 37 days, but if you go 30 days, which is exactly 7 days less, you get right back to the Monday. Similarly, 23, 16, 9, and 2. And then we have to go 2 more to get to Pat. So 1, and then Pat's birthday, which would be right here. So Pat's birthday is on a Saturday. You see how I did that? Just going back multiples of 7. And I had to go back 37 days. Now I do the exact same thing to figure out what day of the week is Julie's birthday. And she is 67 days before Pat. Okay, so the same thing, subtract multiples of 7. So we've got 60 and 53, 46 and 39, 32, 25. Let's see here, 18, 11, and 4. So this is 3, this is 2, this is 1, and this is Julie's birthday. So Julie is on a Tuesday. So number 18, the answer is D. The whole numbers from 1 to 1,000 are written. How many of these numbers have at least 2 sevens appearing side by side? So the first scenario will be if you have a number of this form where you have 7, 7 like that, and then the other digit can be anything. And that digit can be anything from 0 to 9. So that's 10 possibilities, right? So there's 10 of these guys. 10 numbers that look like that. Then the other possibility is if you have a number like this, 7, 7, where this can be anything from 1 to 9, right? Can't be a 0 because that would not make it a 3-digit number. Because I'm initially talking about 3-digit numbers. So how many of these guys do you have? Well, 9 of those. And then 2-digit numbers, that's relatively easy. There's only one possibility, and that's 7, 7. So there's one of those guys. Now keep in mind, they are saying at least 2 7s. So you can also have 3 7s. And 3 7s, well, there's obviously only one way of doing that. So there's one of those. So in total, I've got 10 plus 9 plus 1 plus 1. And that is 21. But this question is a bit tricky here. I think a lot of hearts have been broken because of this question, because 21 is not the right answer. You say, why? It seems like everything made sense, right? Because we overcounted. Overcounting is a very common mistake on math contests. And it's, like I said, it's very disappointing because it often happens on easy questions that you definitely know how to do, but you overcount it. Why did we overcount? Well, because in this category, one of the numbers is 777, right? It's when this third digit becomes a 7. In this category, one of the numbers is also 777, correct? When one of these is a 7. And then over here, we have that 777 again. So this number, 777, was counted 3 times. So we have to subtract 2 of them from our total. And therefore the answer is 19. Okay, so don't feel bad if you got this wrong. Number 19, the answer therefore is E. In the diagram, the square has a perimeter of 48, and the triangle has a height of 48. If the square and the triangle have the same area, what is the value of x? Square, we'll just call it y in terms of its side length, and they tell you that the perimeter is 48. So that means that 4y is equal to 48, and therefore y is equal to 12. And then they tell you that the square and the triangle have the same area. For the square, its area is y squared, and therefore that's 144. The triangle has the same area, so the triangle, that area is also 144. But to calculate the area of the triangle, it's 1/2 base times height. Base in this question, they have labeled it as x, and the height they've told you is 48. So we have to solve this equation. So it becomes 144 is equal to 24x, and therefore x, 144 divided by 24, is 6. So number 20, the answer is C.